Consider this question. This is another typical question which is based on reduced instruction set computer system. Okay, here the question is as follows. Consider a RISC machine where each instruction is exactly 4 bytes long. One instruction is 4 bytes. Conditional and unconditional branch instructions use program counter relative addressing mode with offset specified in bytes to the target location of the branch instruction. We will see what it is in a short while. Further, the offset is always with respect to the address of the next instruction in the program sequence. Consider the following instruction sequence. Okay, there is a note. One word is 32 bits and memory is byte addressable in RISC. And again, we'll discuss in a short while. Now let us have a look at these instructions. These instructions are as follows. The first instruction is add R2, R3, R4. Fine. Second instruction is SUB R5, R6, R7. The third instruction is compare R1, R9, R10. Okay. And the fourth instruction is branch if equal R1, offset. Let us see what it is. If the target of the branch instruction is I, then the decimal value of the offset. We are asked about the decimal value of the offset. Okay. So now let us understand this question completely. Okay. The thing is, here he is talking about a RISC architecture, and he told that the designer of the question admitted that one instruction is 4 bytes. Of course, in RISC, one word is 32 bits. 32 bits meaning 4 bytes. And memory is byte addressed. You know what is byte addressable? In 32 bit, one word is equal to 4 bytes because one word is equal to 32 bits, which is equal to 4 bytes. So each byte will be given an address. So one word will be equal to 4 addresses. Okay. Now, conditional branch instructions use relative addressing mode. Relative addressing mode, you know what is a relative addressing mode? In relative addressing mode, the address part of the instruction will be added to the program counter value, right? The address part of the instruction will be added to the program counter value in order to find out the target address of the branch. So the program counter value is address in the instruction. The program counter value will be effective address is equal to program counter plus address in the instruction. Okay. Now, this is how we are going to calculate the effective address in relative addressing mode. Which is used in the system. Okay, now the question is, there is a program, and here the fourth instruction is branching to the first instruction. That is, if the target of the branch instruction is I, then the decimal value of the offset, that is, this fourth instruction is branching to the first instruction, that is I. So if at all the fourth instruction has to branch to the first instruction, then he's asking what is the offset, that is the address part of the instruction. You know that this offset address part of the instruction will be added to the program counter value, which holds the address of the next instruction, right? The program counter holds the address of the next instruction. Okay. Now let us have a look at what will be the program counter value. Okay. In our program, when you write the program, of course, as one word gets 4 addresses. If we consider the first address is equal to 0, Next address offset will be equal to 4. Next instruction offset will be 4. The next instruction offset will be 8. This instruction offset will be 12, right? Then the program counter value will be equal to 16, right? So the program counter value PC is equal to 16. Once again, this is a program. When you write this program, when it is not loaded into the main memory, you consider that the first instruction will get the first address, that is the 0th address within the program. Okay, as we are implementing in a RISC architecture, in the RISC architecture, one word is equal to 4 addresses, right? So then the next instruction address will be 4. Because the first instruction occupies 4 bytes, each byte was given an address. And the next instruction offset is 8. And the next instruction offset is 12. The program is over. Okay, for this, rather, the instructions within the program given here is finished. Now the program counter value is 16 because next instruction to I plus 3 is I plus 4, that is 16, right? So now, this is a branch instruction branching to ith instruction, which is having an offset 0. Now, how to calculate effective address? Effective address is equal to program counter value plus address of the instruction, address in the instruction, Effective address already we know, that is ith instruction offset. That is, we are branching from this location to this location. What is the offset of this location? This is the 0th location. So effective address is already 0. Okay, now then, what is the program counter value for this? The program counter value for this is 16. Okay, 16. Now we need to find out the offset, that is the address in the instruction. Address part of the instruction, rather the address within the instruction, both are one and the same. We need to find out this offset. 16 plus x is equal to 0. Okay, then x is equal to minus 16. This is the answer. Minus 16 is the answer. So offset, which is equal to x, is minus 16. So the offset is equal to minus 16. Just have a small revision of this question. This question is talking about RISC architecture, right? In the RISC architecture, one word is equal to 32 bits as given in the question. There is a program given. In that program, 4 instructions are given, right? In those 4 instructions, the 4th instruction is branching to the first instruction. The 4th instruction is branching to the first instruction. So when you write the program, you consider that the first instruction address will be obviously 0, right? The first instruction address will be obviously 0. Second instruction address will be 4. The third instruction address will be 8. The 4th instruction address will be 12. Program counter value for the 4th instruction is 16, right? Now, this 4th instruction is branching to the first instruction. Okay, that is effective address for this instruction while branching is 0. The branch target address is equal to 0. And now here this architecture is using relative addressing mode. In the relative addressing mode, effective address is equal to PC value plus address part of the instruction, which is specified in the offset. Okay, now we know the effective address, we know the program counter value. Okay, then x is equal to 0 minus 16, which will be equal to minus 16. This is what the answer is. Minus 16 is the offset. Okay, here in the offset part, if we can put minus 16 plus 16 is equal to 0. So the exact branch to the 0th location will be made.